Hello, ladies and gentlemen of my 3C class. Our topic today is transformations of parabolas, and our goal, I can locate the vertex of a parabola using its equation, and I can graph all other points on the parabola by using the vertex as my starting point. We're going to look at the pattern first here. So we're talking about the transformations of the parabola. In the last video, we talked about how to use the equation to find the vertex. But I'm going to go back to the very basic parabola right now. This is just the y equals x squared. This is the simplest possible parabola we can get, where in order to get our y value, what we do is square the x value. So I'm showing you the table of values, and here we take our x value, and when we square that x value, we get the y value. So -3 times -3 gives us 9. -2 times -2 gives us 4. -1 times -1 gives us 1. And if we go back up the positive side, we get the same answers. And that's what gives us the symmetry of this parabola. So take a look at this. Woohoo! There's our symmetry of our parabola. And I just want to show you in relation to the vertex how we're going to get all of the other points on here. So, and it's because of this table of values, because of this very basic parabola, that we can say that this pattern exists. So here we go. I'm going to use green to show this. Now, first of all, notice that this is 1 unit, 2 units, 3 units. The grid marks every half unit. So I'm just going to put on the rest of these numbers that are on here. 7, there's 9. Okay. So when I go over 1 unit of space, right here, when I go over 1 unit of space from the parabola, I go up 1 unit of space. Okay, so it kind of looks like we're going, whatever you go over, you go up. Well, let's take a look at the next one. If I go over 2 units of space, right here, there's 2 units of space. No, I'm going up more than 2. Look at that, I'm going up 4. Okay, there we go. So it was 1 and 1 to start with, which would have been really easy to remember, but then it goes over 2, up 4. So that's not quite as nice. Let's take a look at 3 and see if we can find some sort of pattern here. Over 3, I'm going to use blue for this one. Oh, that's not a very good bracket, but anyway, over 3, we're going up to this one, and that's at 9. So when I go over 3, I go up 9. So it looks like my up is getting bigger and bigger all the time. But can we find some kind of a pattern? Well, take a look at this. When I went over 1, I went up 1. When I go over 2, I go up 4, but 4 we know to be 2 squared. Let's think of that in terms of how we got these numbers in the first place. So when I went over 2, I go up 2 squared, which is 4. Does that work for the next one? When I go over 3, I go up 9. Is 9 3 squared? You betcha, 9 is 3 squared. Now notice that it doesn't matter whether I go to the right or to the left of the parabola, I'm still getting the same up value. These dots here on this side of the axes are the same distance above the axes as the rest of them. Okay, so now before we go on, I'm going to pull over this line and I'm going to mark it on as the axis of symmetry. So you remember we talked about what the axis of symmetry was. It's the line that goes right down the center and it has to pass through the vertex point. So I'm just going to mark on a couple of things on here. I'm going to mark on that this is the axis of symmetry. Axis of symmetry. And that this down here is the vertex, and the vertex of this parabola is at 0, 0, because this is the regular parabola. It has not been transformed in any way. Now we saw in the last video what happens when we move around our vertex. So I'm just going to summarize this here. We already talked about this, but we're going to summarize it in this table. Notice that for each horizontal distance, you move away from the vertex, you move up that same distance squared. That means you multiply it by itself. So I'm going to highlight the term squared. This happens whether you move left or right. So we're just going to fill in this table, left or right. If we move 1 unit, we go up 1 squared, which is 1. If we move over 2 units, we go up 2 squared, which is 4. Over 3 units, we go up 3 squared, which is 9, and then that took us right off our chart. We didn't have any more dots after that on our parabola. But we can imagine carrying on this pattern where if we went over 4 units, we go up 4 squared, which is 16. 5 units gives us 5 squared, which is 25. And then notice I've got the dot, 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 and it says n units. Well, this is just the way we say it doesn't matter how many units we go, we know that I'm going to have to multiply that by itself and go up n squared units. Now, how are we going to use this to graph? Well, let's take a look. For each of these, we're going to state the vertex of the parabola and then graph it using the pattern we just discovered. So here, this is one that we looked at yesterday. The vertex of this parabola, remember we take these two numbers, and this one we have to take the opposite sign. So this is going to be -2, -7. Now we're going to put that on this graph. So -2, -7 means I go back 2 and down 7. 1, 2, 3, 4, 5, 6, 7. Right there. Now according to the little pattern we just saw, we're going to go over 1, up 1 squared, which is 1. Over 2, up 2 squared. 2 squared is 4, so 1, 2, 3, 4. Over 3, up 3 squared, which is 9. So there was our 4, 5, 6, 7, 8, 9. Now remember, it doesn't matter what part of the parabola we're on. And let's see if we can get one more on here. Over 4 was up, what was it up? That's right, it was up 16. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, we just got under the wire. It actually fits on there. And we'll go and do it on the other side. Now, if you get a parabola that's too pointy, that say the ends went out like a straight line like that, then you know you've done something wrong. It should be a nice curved line, and the distance between the dots gets more and more the farther away you get from the vertex. Okay, so there's our parabola. Now, let's do the next one, part B. This has brackets, but there's nothing on the end, so we know we're looking for these two numbers, and since this number is missing, we know it must be 0. So this is 6, because remember we take the opposite sign. I'm just going to put opposite there again. 6, comma, and since there was nothing on the end, we're going to put 0. So here we go, forward 6 spaces. 1, 2, 3, 4, 5, 6. And we don't go up or down. There's our parabola. Now remember, over 1, up 1. Over 2, up 4. Over 3, up 9 is way up here. And we do the same thing on the other side. There we go. Okay, same thing on the other side here. Over and up, over and up. And then we should draw our nice smooth curve through those points. Now we're going to keep going. I'm going to try and do this as fast as I can. Now this one here, it has no bracket, so there's something missing from there. Remember, we need these two. We need the number in the brackets and the number on the end. Now the number in the brackets, there's no number in the brackets, so it's got to have been 0. And then the number on the end is 5. So 0, 5 is our vertex point. Now remember, over 1, up 1. Over 2, up 4, which is 2 squared. And that's all we can do. There's no way I'm fitting any more points on here, so I'm just going to draw what I can in the space that I have. Next one, what's the vertex of this one? Remember, we got to take these 2 points. Now this one we take the opposite sign, so it's going to be -4. And then a 1 on the end. So -4 means I have to go back 4 spaces. 1, 2, 3, 4, and up 1. Right there. And now, again, this is just a regular old parabola. Over 1, up 1. Over 2, up 4. Over 3, up 9. I'm not going to fit that on there. Oh, wait a minute. Just under the wire. Yep, I am going to fit it on there. Just right there. Okay. Booyah! Put that in there. Okay, now let's see how quick I can graph the last 2 here. What's the vertex here? Remember, we're looking for these 2 numbers, but we got to take the opposite sign here. Opposite sign. So that's going to be a +3 and a -6. So we go forward 3 and down 6. 1, 2, 3, 4, 5, 6. Let's see how many of these we can get on. Over 1, up 1. Over 2 up 4. Over 3 up 9. 4, 5, 6, 7, 8, 9. Can I get one more on there? Over 4 was up what? 16? Yep, 16 is 4 squared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, we just got her on there. And we put the other one there. And there's a nice curve. Round and round and round we go. Last one. Here we go. We want these two numbers. That's going to tell us our vertex. And we take the opposite sign. So -1, +3. -1 up 1, 2, 3. There we go. And you remember it? Over 1 up 1. Over 2 up 4. 1, 2, 3, 4. Over 3 up 9. That's not going to fit. So we're left with this. And that brings us to the end of this video. Now you try a few. Over and out.